So in this question we're told that in a geometric pattern each term is found by multiplying the last term by a number, and for the geometric pattern below we're asked to find the sum of the first 6 terms. So we're given the first 3 terms of the pattern here, so we're given t1, t2 and t3, and we're looking again to find the sum of the first 6 terms, so we need to find the next 3 terms, or alternatively use our formula for the sum, which I think is easier. So you can basically do this 2 ways. You can either manually find the sum, or you can actually just use the formula. But the very first step here is going to be to find the common ratio, because we're only given 3 terms here, we're not given the ratio. And if we look at our formula for the sum, it is going to be that Sn, or the sum to term n, is going to be a times 1 minus r to the power of n divided by 1 minus r. And so we have all the information we need here except the ratio, and so to find that we can simply take a term, which is not the first term, so we're going to take the second term, which we know is 12. So we're going to have 12, and we're going to have to just divide this by the term that comes before it, so t2 over t1. We could also do t3 over t2, but I think it's just more straightforward to do the first two. So 12 divided by 3 is going to be 4, so that is going to be our common ratio r. And so now to find the sum to the 6th term, we can simply use our formula. So we're going to have to find S6 actually. So S6 is going to be a, which is the first term. Actually, you should label that as well. So a is going to be 3 here, so we have a and r now. So we're going to have 3 on the top of our little fraction times 1 minus r to the power of n. We know that r is 4 because we found that, and n is going to be 6 because we're going up to the 6th term. And then on the bottom, we're just going to have 1 minus 3 as well. And I actually spotted a mistake as well in how I'd written it. I'd actually had 3 in the bottom here, where it should have been 1 minus 4 in the bottom. But now that we've got that, we can just plug all the numbers in, and we're going to see that using our calculator. If we simplify this, our sum to the 6th term is going to be 4,095. As you can see, it's actually quite a large number, even though our first 3 numbers in the pattern are relatively small. And so it is probably easier to use the formula for this one. But that is going to be our sum to the 6th term, and so that is going to be it for this question.